It's now time for us to expand our discussion of attaining unicast connectivity on a per-link basis to multi-access links. Specifically, we're going to limit our discussion to a switched Ethernet network using a Catalyst 3560. We're going to just take two simple routers here, R1 and R2, and we're going to connect them via a LAN switch, and we're going to put them in the same VLAN with each other. Obviously, configuring an IPv6 address on an Ethernet interface is a very simple task. So what is the primary difference between attaining unicast connectivity on an Ethernet segment as opposed to a frame relay or point-to-point connection? One difference is the use of the neighbor discovery process and the neighbor discovery table. With a multi-access interface, the neighbor discovery process acts as the IPv4 ARP process. It is very important to note that there is no ARP process with IPv6. The ARP replacement process is the ICMP neighbor discovery process. For every remote unicast destination address, there must be an IPv6 unicast address to unicast MAC address mapping in the show IPv6 neighbor table. Let's take a look at this at the command line. Let me go to R1. And let me go ahead and do the show IPv6 neighbor command. When I type the show IPv6 neighbor command, unicast IPv6 addresses are mapped to unicast MAC addresses in a manner that is similar to an IPv4 ARP table. To reinforce this idea, let's take a look at the IPv4 ARP table. To do that, we'll just type show ARP. So what is the difference between the IPv6 neighbor discovery process and the IPv4 ARP process? The ARP protocol is separate from the IP protocol. It uses a broadcast destination address in ARP request messages to map an IPv4 unicast address to an Ethernet unicast MAC address. Again, it is important to note that the ARP protocol does not use an IP header when ARP requests and replies are generated. The ARP replacement for IPv6 is not separate from the IPv6 protocol. It involves two ICMP message types that are unique to IPv6. The ICMP v6 neighbor solicitation message, type 135, and the neighbor advertisement message, type 136. These two ICMP message types are encapsulated inside of an IPv6 header. While IPv4 ARP messages use a broadcast address as the destination, IPv6 neighbor solicitation messages use a special multicast address called a solicited node multicast address. The solicited node multicast address begins with a specific prefix that we will see in a moment, and then the last remaining 24 bits of this multicast address are extracted from the destination unicast address specified in the ICMP v6 neighbor solicitation message. By the way, this address is also discussed in our IPv6 multicast video on demand, as you might guess. We can actually see the solicited node address with the show IPv6 interface command. Let's try it here at the command line. I'll say show IPv6 interface Ethernet 0. Notice we can see this solicited node multicast address. They begin FF02 and then they're going to end with, actually as we can see here, with 24 bits borrowed from the link local address. So we're borrowing bits from the link local address to create this solicited node prefix. We can actually prove this. Let's go to this interface and let's say interface E0 IPv6 address, and I'll say FE80 A:BC link local. So what we're doing is we're creating a new link local address for this interface. Now if I do a show IPv6 interface E0, we see that we have our new link local address, and we ended it with ABC. And if we look down here, we see that we have our new solicited node multicast address, it also ends ABC. Now let's take a look at this IPv6 neighbor discovery process using two routers over a single Ethernet segment. Let's begin with the following simple configurations on routers R1 and R2. All we're going to do, if you show run interface Ethernet 0, is configure an IPv6 address, which I've done. So we have an IPv6 address on R1 and R2. That's all we need for configuration here. When we go ahead and ping one from the other, for instance, ping 2001:1:2, so I'm pinging from R1 to R2, we are going to create mappings in the IPv6 neighbor table. And here you can see the mappings. Notice that there are two different IPv6 addresses referencing the same exact MAC address. So we have two entries in here referencing the same MAC. What are these two different addresses? Well, sure enough, one is the global unicast and the other is the link local. So there we see the global unicast and the link local for this particular destination. Notice that in this case we have one marked as reach and one marked as delay. If we go over to R2 and do a show IPv6 neighbor and look at the neighbor table over there, we see that here we don't have any marked as reach. We have entries marked as stale. What's going on? Well, first of all, this stale state is attained when a listed address that was formerly in a reach state has not been used for a period of time that exceeds the IPv6 configurable parameter of IPv6 neighbor discovery reachable time. Interesting. This would look like this at the command line. So we can configure an IPv6 neighbor discovery reachable time value. And notice this is going to be entered in milliseconds. So if we have a stale state, we've exceeded this time. We haven't used the entry in that time. If we have a reach state, we have used the entry within that time. Now let's attempt to ping a non-existent IPv6 unicast address on the segment, and let's look at the neighbor solicitation messages that result. So let's go ahead, we can do it right here at R2. Let me go ahead and say debug IPv6 neighbor discovery. And now let me go ahead and ping a non-existent address. I'll ping 2001:1:10, and we'll repeat just once. We'll just send one packet and we'll see the messages that result. We're of course not going to meet with success. Now notice what happens here. We see that there are 3 neighbor solicitation messages generated for this address, and then we see that we go through some state changes, don't we? We have a delete state and an incomplete state. Initially, the IPv6 neighbor discovery went from, let's scroll up to look at this. Initially, it went from delete to incomplete, and then after the 3 neighbor solicitation messages, it went from incomplete to delete. So very interesting. We have these different states, and we see that we're incomplete. We're trying to attain the correct information, the resolution of layer 3 to layer 2. When we cannot, we go from the incomplete to the delete state. So these states are named well. They make a lot of sense. Let's try this again, but let's use a different tool. Let's go ahead and turn off the debugging that we were doing there, and let's do a debug IPv6 packet detail. Debug IPv6 packet detail, and let's initiate that ping again. Let's look at these messages. Alright, when we look at these messages, we see that 3 packets go out using the solicited node multicast address as the destination address. These three packets are the IPv6 neighbor solicitation packets. So look at this. We can see that we are using that solicited node multicast destination address as the destination for these packets. And that would make sense. We're trying to do the neighbor solicitation process so we can build this resolution table. And here we can see the destination of these packets is indeed the solicited node multicast address. Something else that we can do, in addition to having this address resolution occur dynamically, is we can build static mappings for the IPv6 unicast address to an Ethernet MAC address. You can build a static mapping. You can go in and you can say, in global configuration mode, IPv6 neighbor 2001 1::10 Ethernet 0, and then provide a MAC address. So you can do static mappings in the table, and that is the syntax that you would use to do it. If we verify this with the do show IPv6 neighbors command, you're going to see that the entry that we manually put in the table is not going to feature an age value, and it's going to be permanently in that reach state. So very, very interesting. We actually have two options for mapping an IPv6 unicast address, therefore, to a MAC address, and one is dynamic and one is static. Once again, very important to know your configuration options when it comes to IPv6, or for that matter, any topic. Now, we used a 3560 to provide the switch connectivity between these routers. Let me stress to you that while the 3560 does support IPv6, it's not configured to do so by default. What we need to do to provide IPv6 support on the 3560 is to go ahead and utilize the SDM command. The SDM command stands for Switch Database Management. So we issue the command SDM prefer dual IPv4 and IPv6 routing. We then reload the 3560, and then we can confirm this configuration with the show SDM prefer command. So if we want the 3560 to fully support IPv6 routing, we need to make this configuration change on the 3560. Well, I hope you've enjoyed this video on demand regarding unicast connectivity and specifically a multi-access link. And we look forward to your participation in future video on demands.